Welcome back. Today we are going through lesson 7.5, which is all about solving radical equations. So we're going to start by going through the process and the steps in order to solve, and then we'll do a bunch of examples together. So in our solving process here, when we have a radical that we're trying to solve for, we have three main steps that we're going to do, and then we always want to check our answers at the end. So in this one, you can see our original equation there, negative 10 plus the square root of 3x minus 3 equals negative 7. So the first thing that we're always going to do before we can solve this is we are going to isolate the radical on one side of the equation. To do that, we're going to use inverse operations of whatever we need to do to get that radical by itself. So anything outside the radical on that side of the equation needs to be moved using inverse operations to the other side. Once that radical is isolated, then we need to get rid of the radical essentially. So what you're going to do is you're going to square or cube both sides of the equation in order to eliminate the radical. So the inverse of square root is squaring it, and the inverse of cube rooting is cubing it. So we use whatever we need inverse operation-wise to get rid of the radical. Once that radical is gone, now it's generally a pretty basic equation to solve. So we're going to solve it for x using either inverse operations, or sometimes we'll be left with something that has to be factored. So that gives us an answer. So we'll end up with x equals something. If we had to factor, we may end up with 2 possible x values. And then the last thing that we are going to do is we are going to check our solutions by substituting. So taking that answer, plugging it back in for the x value and seeing if it comes up with a true statement. And we're checking for extraneous solutions. So extraneous solutions are where you get an answer to the equation, you solve for x, you get an x value, and then when you plug it back in, it doesn't actually give you a viable solution. So we'll look at some examples of that in a second. We can also check our solutions graphically. So we can graph the two equations, or the two sides of the equation. So in this one, we're trying to figure out where y equals negative 7. We know for this one, it's going to start down here. And again, you can do this on a calculator or you can do it by hand. But basically, it's going to come up right through this point and look something like that. And then we find that intersection point, and we can see that that intersection point is indeed at 4. You can also use your calculator and different methods depending on which calculator you're using. For the 84, you can see we enter the equation, so negative 10 plus the square root of 3x minus 3, and then you hit these buttons. So you hit alpha trace, so you're following along that curve of the radical, and then you want y1, that's the function that we put it into. You hit enter, and then you type in y1 of 4, and then enter again, and you will confirm that the answer was indeed 4. So different calculators have different methods to check that, but you can use your calculator, not just the graph part, but also the equation part in order to figure things out. So what we're going to do now is we're going to go through some examples of solving. So we're going to follow those steps that we just did. So the first thing I need to do in example A here is I need to isolate the radical. So I need to get rid of this 2 out in front. It's being multiplied, so I'm going to divide. So that's where those inverse operations come in. When I do that, I'm left with the cube root of 5x plus 14 equals 4. And then we do step 2, which is to get rid of the radical. In this case, it's a cube root, so I am going to cube both sides in order to eliminate that radical. So on the left side, that just gets rid of the radical, and we're left with whatever's inside. On the right side, we have 4 cubed, which is 64. And now, like I said, we end up with a pretty basic equation to solve. So we're going to subtract the 14 from both sides. That's going to give me 5x equals 50. I'm going to divide out the 5 on both sides and get a solution of x equals 10. Then always, 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 you need to check your solution. So remember, the algebraic way to do that is to plug in the solution you just got and see if it gives you a viable answer, an answer that actually makes sense. So I'm going to replace the x with the 10, and then I'm going to solve it. So I'm basically just going to simplify that left side. So this leaves me with the cube root of 50 plus 14, which is the cube root of 64. And I know the cube root of 64 is 4. So I have 2 times 4 equals 8. So since 8 equals 8, we know that it's a solution. So 10 is the solution to that equation. Okay, let's look at the next one. So example B here, we have to remember that a fraction exponent is the same as a radical. So remember, in fraction exponents, the numerator is the power and the denominator is the type of radical you're taking. So I'm going to rewrite this instead of to the 1/2 power as the square root of negative 4 minus 13x. So I can see now that it is a radical equation that I'm going to solve. So I'm going to eliminate some key things here. So the first thing I'm going to do is I am going to move the 5 over to the other side by subtracting it. So when I do that, I'm still left with the negative 4 out in front and my whole radical, but now it's equal to negative 40 because I subtracted that 5 over to the other side. Then we also have a negative 4 out in front that's being multiplied, so I'm going to divide both sides by negative 4. And when I do that, I get a positive 10 on the right-hand side. Okay, so now I have isolated that radical. Now I'm going to get rid of the radical. This is a square root, so I'm going to square both sides. When I do that, I get negative 4 minus 13x equals 100. And now I have a more basic equation to solve. So using inverse operations, I'm going to add 4 to both sides and get 104. And then lastly, I'm going to divide both sides by negative 13. 104 divided by negative 13 is negative 8. So that's the solution. Now I'm going to come over and check it algebraically. So I'm going to plug it into my original equation. Always go all the way back to that original equation, not any of your steps, just in case you made any mistakes along the way. It'll help you to figure it out. So we're trying to figure out, does this actually equal negative 35? So when I do this, I'm going to start by just simplifying that whole inside. So again, I'm going to write it as the square root. And if I do negative 13 times negative 8, and then do negative 4 plus that number, I end up with 100 inside that root. And then I have plus 5 out here. So the square root of 100 is 10. And now I have negative 4 times 10, which is negative 40. And negative 40 plus 5 is negative 35, which does equal negative 35. So my check works. It's a viable solution. All right, example C here, same idea. Now I have a fraction, so I'm just going to isolate that radical still. So I'm going to multiply both sides by 2 to get rid of the fraction, or the denominator of the fraction. And then I still have that minus 10, so I'm going to add 10 to both sides in order to isolate that variable. So here you can do a couple different things. If you know the square root of 16, if that kind of triggers in your brain that that's something you know, you can simplify this into the square root, or 4 square roots of x, because the square root of 16 is 4. So we can pull that out. If you don't recognize that and you just square both sides, you're going to end up in the same spot, just slightly bigger numbers. So if we simplify that square root of 16 into 4, now I have to move that 4 to the other side. So I'm going to divide both sides by 4. That leaves me with the square root of x equals 2. So I've got that radical isolated. I'm going to square both sides and get that x equals 4. So let's check that, make sure it works here. So we have the square root of 16 times 4 minus 10 over 2. And we want to know, does that equal negative 1? So when I do that, the square root of 16 times 4, that's the square root of 64, which is 8, minus 10 over 2. And 8 minus 10 is negative 2 over 2. So I do get that negative 1 equals negative 1. So that works. So x equals 4 is our solution. Okay. Example D. So for this one, I can see that on the left-hand side, I have the cube root, but on the right-hand side, I also have a 1/3 power. So what that means is that I have a radical, in this case, cube root, on both sides. So if it's on both sides, we can't isolate one or the other. So we're just going to skip to step 2 because they're the same type of radical. When I cube both sides, both the radicals are going to be eliminated. So I'm going to be left with x minus 6 equals 49 minus x. So now I have a more basic equation to solve. I've eliminated the radicals completely. So a couple different ways you can go about this. But the first thing that I would do is I would eliminate that divided by 6 on the left-hand side. So multiply both sides by 6. We're going to get x on the left-hand side. When I multiply 49 by 6, I get 294. And then x times 6 is 6x. Now I'm going to get my like terms together. So I'm going to add 6 to both sides. So that would leave me with 7x's on this side and only 294 on the right side. Divide by that 7 on both sides, and we're going to get that x equals 42. So let's see if that works in our check. So I have 42 divided by 6 inside that cube root, and then I'm going to write this one as a cube root, and I have 49 minus 42. So 42 divided by 6, that's 7. And then on this side, I have 49 minus 42, which is also 7. So I can see there that I have the cube root of 7 equals the cube root of 7. You could take it down to decimals if you want, but you don't have to. As soon as we see that both sides are exactly the same, we know that 42 is our solution. Okay, last example here. So in this one, I can start by isolating that radical still. So I'm going to get rid of the negative x by adding it to both sides. Now I have to get rid of the radical, so I'm going to square both sides, but what I see here is I no longer just have one thing I'm squaring 2 terms. So I am going to have to multiply that out. When I do that, the left side is still 5 minus x, but when I multiply 1 plus x times 1 plus x, and I FOIL it out or I use a box or whatever method you want, we end up with 1 plus 2x plus x squared. So this one has an x squared, which tells me that I am going to have to factor it. So in order to factor it, I'm going to have to get it equal to 0. So I'm going to move everything around. I'm going to get this side equal to 0. So I've got an x squared on that left-hand side. I'm going to move it to the beginning just to write it in standard form. I had 2 x's on the right-hand side, but I'm adding an x from the left-hand side, so I now have 3x. And then I had a 1 on the right-hand side. I'm subtracting 4, so that puts me at -4 on this side now. So now I'm going to have to factor this quadratic that I have left. So I'm trying to think of 2 numbers that multiply to -4 and add up to +3 for my factor. My factors on this one are going to be x plus 4 and x minus 1. Because 4 times -1, that gives me the -4. 4 minus 1 gives me the +3. So my solutions, therefore, what would make that equal 0? X could be -4, and x could be 1. Okay, so let's check. So this one we're going to have to check both solutions here. So let's see what happens here. When I plug in a -4, I have a -4 plus the square root of 5 minus -4. So I'm going to write that as +4 equals 1. All right, so this would become a +4. 5 plus 4 is 9, so I have the square root of 9, which is 3, and I can see that I get 7 equals 1, and that is not true. So that means that this -4 that I got as a solution is extraneous. It doesn't work when I plug it back in. Okay. Now, let's check the other one, see if 1 works or if I have 2 extraneous solutions. So -1 plus the square root of 5 minus 1 equals 1. So here I have -1 plus the square root of 4, which is 2, equals 1. So that would give me 1 equals 1. That does work. So that means that x equals 1 is a solution. Negative 4 is an extraneous solution. Okay, now we are going to do some practice problems. So I would encourage you to pause this video and try these problems on your own, and then come back and listen and watch and see if you end up in the same spot or if there's any mistakes you need to correct. So for our first example here, we have a cube root, so I'm going to isolate it by adding 7 to both sides. So that's going to give me 5. Get rid of the radical by cubing both sides because it's a cube root. 5 cubed is 125. And then I'm going to subtract 18 from both sides. 125 minus 18 is 107. So let's just double check that that works before we officially say it's our solution. So I have 107 plus 18 equals negative 2. So I have negative 7 plus the cube root of 125. So that would be negative 7 plus 5 that I want to equal negative 2. And negative 2 does equal negative 2. So we are good. 107 is our solution for that first example. Okay, example 2 here. So again, I can rewrite that 1/2 power as a square root. So I'm going to isolate that square root now by subtracting 7. And then I'm going to eliminate the radical by squaring both sides. And then this one, the last thing we have to do is eliminate that 50 by dividing both sides by 50. So we get 2 equals x. All right, let's double check that that works. So when I plug it back in, I have 50 times 2 to the 1/2 power plus 7. So that's going to be the square root of 100 plus 7. So 17 equals 10 plus 7. That would be true. 17 does equal 17. So that means that 2 is our solution. All right, number 3 here. I've got radicals of the same type on both sides, so I don't need to isolate one. I just need to eliminate those radicals. So I'm going to cube both sides to get rid of the cube roots. That's going to leave me with 3x equals 2x plus 3. Now I'm going to get my like terms together, so I'm going to subtract 2x from both sides. That's going to leave me with 1x and a 3 on the right-hand side. So x equals 3 is the solution. Let's double check it. So I have 3 times 3 on this side, and on this side I have 2 times 3 plus 3. So 3 times 3, that's going to give me the cube root of 9 on this side. And on this side, we have the cube root of 6 plus 3, which is also 9. So again, you can take this down to the decimal to make sure they match, but the cube root of 9 equals the cube root of 9. Means that 3 is a viable solution. Okay, number 4. On this one, I can see that I have that square root on the right-hand side written as a fractional exponent. So I'm going to square both sides to start with in order to eliminate that. So I'm going to be left with just 8x minus 15 on this side. So again, on this one, I can see that I have an x squared, which means that I'm going to have to factor to solve. So I'm going to get it equal to 0 by moving the 8x and the 15 over to that side. And so now I'm trying to factor two numbers, or I'm looking for two numbers that multiply to 15 and then add up to negative 8. So I know they're going to have to be negative. Negative 5 times negative 3. That was going to give me positive 15, and negative 5x minus 3x is going to give me the negative 8. So in order for that to equal 0, my solutions are going to be 5 and 3. So let's double check that those work. Since I have 2 of them, I'm going to divide this up. So I'm going to say 5 equals the square root of 8 times 5 minus 15. Let's see if that works. 8 times 5, that's 40 minus 15. 40 minus 15 would be 25, and the square root of 25 is 5. So 5 works. Let's see if 3 works now. So now I have 3 equals the square root of 8 times 3 minus 15. So when I simplify that right-hand side, I have 24 minus 15, and that is 9. The square root of 9 is 3. So 3 is also a viable solution. So in this one, we don't have an extraneous solution. Both solutions work. Okay, for our last one here, I can see that I have that negative x out in front, or out behind the radical, so I'm going to move that to the other side. So I have negative 8 plus x, and then we're left with just the square root on this side. Okay, so I'm going to square both sides. And again, when I do that, I have to multiply out this whole 2 terms. So when I do that, I am going to get x squared minus 16x plus 64. And on this half, I have negative 8x plus 52. So I can again see I have an x squared, which means I'm going to have to get it equal to 0 to solve. So I'm going to move the negative 8x over. So I'm going to add 8x to the left side. And then I'm going to subtract 52, which is going to put me at 12. So that is what I'm going to have to factor in order to solve this equation. So when I factor it, 2 numbers that multiply to 12 add up to negative 8. That would be negative 6 and negative 2. So my solutions would be 6 and 2. Now let's check them both to make sure they're both viable solutions. So we are trying to get it to equal negative 8. So I have the square root of negative 8 times 6, that's negative 48. Just in the interest of space, I'm going to go ahead and plug that in and simplify it. Okay, so I have negative 8 equals the square root of 4 minus 6. So that, square root of 4 is 2. 2 minus 6 is negative 4. That does not equal negative 8. So that tells me that 6 is an extraneous solution. It did not work when I plugged it back in. So let's see if over here if 2 works. So same idea, I'm going to plug it in. Let's see, negative 8 times 2, that's negative 16 plus 52, all inside my square root. And then we're subtracting 2, so, oops. Negative 8 equals, let's see, 52 minus 16. It's going to be 36 minus 2. So now I have square root of 36 is 6 minus 2 is 4. So we can see that that also does not equal negative 8. So in this case, both solutions that we got are extraneous. So you do have to make sure you check both. It is possible in these situations that you could have no solution. It means that the radical function never intersects our vertical line at negative 8. All right, that is all about solving radical equations. We'll see you next time.